subject hydrology, chapter hydrograph analysis, topic numerical number 1 on hydrograph. So now students, after understanding about the concepts of unit hydrograph and the concepts of normal hydrograph, flood hydrograph, the direct runoff hydrograph, the concept of ERH, effective rainfall hydrograph, right? Now it's time to solve a numerical based on the hydrograph, right? So what does it say? It says that a 6R unit hydrograph, right? A 6R unit hydrograph of a catchment is triangular in shape. Now these types of questions are very common in gate examinations. Sometimes it is given triangular shape, sometimes it is given trapezoidal shape, right? So it just wants to check your concept, nothing else, right? Their questions are very easy actually, right? Triangular in shape with a basin width of 64 hours. So 64 hours is the base width or the basin width, right? The base width, it should be base width. It should be base width, right? Okay. And peak ordinate of 20 meter cube per second. So it is a unit hydrograph. It means that this hydrograph has been drawn for a depth, for an effective rainfall of 1 centimeter or 1 mm, means 1 unit almost, right? So if a 0.5 centimeter rainfall excess, now this was a unit hydrograph. Unit hydrograph means 1 unit, usually 1 centimeter. Clear? But now it has changed the question. It is saying that if a 0.5 centimeter rainfall excess occur in 6 hours, so we have the same time period 6 hours in the catchment, okay, the resulting runoff, the resulting surface runoff hydrograph will have what? So it's a very straightforward question. First of all, a base of 128 hours, a base of 32 hours, a peak of 40 meter cube per second, and a peak of 10 meter cube per second, right? So now let's go to the assumption of unit hydrograph. Now let us go to the number 4th assumption, the linear response. I told you that whatever change you are doing in a unit hydrograph, the similar change will be there in the you can see the modified hydrograph. For example, if you want to calculate the ordinates for a 2 centimeter hydrograph from a unit hydrograph, you have to multiply the ordinates with 2. Similarly, for 3 centimeter, multiply with 3. But now it is given 0.5 centimeter. What you have to do, it is very simple. You just have to multiply the ordinates of the unit hydrograph with 0.5. You will get the answer. So let me first of all check. This was the unit hydrograph, and unit hydrograph is always made with a direct run. It is a special type of direct run of hydrograph. It means that the base flow is always subtracted, right? This is the discharge, this is your time. So this was the duration of the, and the depth of the was 1 centimeter. Because it is centimeter, so I will be taking 1 centimeter, right? And the peak discharge is how much? It is 20 meter cube per second. So peak discharge is 20 meter cube per second Qmac, right? 20 meter cube per second is 1 centimeter. Now if you want to draw a unit hydrograph of 0.5 centimeter, what you have to do? You just have to multiply the ordinates with 0.5. Right? So what you will be getting, if you multiply 20 with 0.5, how much it will be? It will be 10 meter cube per second. So the shape of the hydrograph will be same, but the peak discharge will be 10 meter cube per second. And this is a hydrograph with a effective rainfall depth of 0.5 centimeter. So just by looking at this example, we can say that it has a peak of 10 meter cube per second is the correct answer. But now option number A and option number B, it also mentions the base. The base. It means that the time. So let us calculate the time also. Although we know that the answer of this question is D, because now no need to look at the what are the 3 options are, right? But the last 2 options were regarding peak, and the first 2 options regarding base. So we have determined that this is the answer. But just for your, you can say, just for your knowledge, let me also determine the base period also. So how much will be the base period for a 0.5 centimeter rainfall? Clear? Now, whenever you are determining any quantity or anything, always remember that the area of the particular catchment, it will not change. Volume may change, right? The depth of the rainfall may change. Infiltration rate can change. Anything can change. But one thing will be constant. What will be that? The area of that particular catchment will never change. right? It will be constant, right? That is just common sense. For example, in geotech engineering also, whenever you are calculating the filling volume, the excavated volume, right? Whatever type of complicated question is there, one thing is not going to change. That is the volume of solids is not going to change. Same goes with the hydrology also. Anything can change, but the area of catchment will be constant. So area of catchment will be constant, right? Now let us calculate the area of catchment. So how to get the area of catchment? I told you that if you calculate the area of this direct runoff hydrograph, you will be getting volume in meter cube, right? If you divide the volume with the effective rainfall depth, or you can also say that effective rainfall, you will be getting the area. Simple, right? Now the area of this catchment, area of catchment. Now how to get the area of this? Although it is not a parabola, in question it has been mentioned that it is a triangular in shape. Triangular in shape. Now let me rub this. And substitute it with a triangle. So this is the actual direct runoff hydrograph, that is a unit hydrograph, right? How much depth of effective rainfall? 1 centimeter. Okay? Now area of catchment will be equal to volume divided by volume of, you can say runoff, volume of runoff divided by effective rainfall, right? So how much is the volume? I told you that when you want to get the volume, just determine the area. So what is area of a triangle? Half into base into height. Simple. So half into base. How much is base? How much is time period? So time period was given to me as, right, base width of 64, yeah, 64 hours. 64 hours is the base width given, right? Half into 64 into height. Height is how much? 20 meter cube per second. But this is second and this is hours. So we have to convert hours into seconds. So this is hours. So 60 minutes in 1 hour and 60 seconds in 1 minute, right? This is meter cube divided by the depth of the effective rainfall. So a unit hydrograph is always, you can say, drawn based on the 1 centimeter or 1 unit depth, right? So 1 unit depth, that is 0.01 meter, right? So you will get the area of that particular catchment, right? So area of this catchment should be equal to the area of this catchment also. This is also triangular. So this is also triangular. But the peak discharge is 10. This is also triangular. Let the base of the catchment is x, right? So it should be equal to how much? Half into base x into 10, right? Into 10, and this is your x will be in hours, so we have to multiply it with, you can say, 60 into 60 to get in seconds, into 60 into 60 divided by. Now how much is the effective rainfall depth? That is 0.5 centimeter. So 0.5, this is centimeter, into 10 raised to power minus 2. 10 raised to power minus 2. That is 0.005. Okay? So can I write it like this? Can I multiply it with 2 and divide it with 2? It was 10 actually. So if you divide it with 2, you will get 10 also. So why I have done it like this? Because you will get the same value. So half will get cancelled out, right? 20 will get cancelled out. 60 will get cancelled out. And in base, 0.5 into 2 will be equal to 1, right? And 1 into 10 raised to power minus 2, that is 0.01. So it will also get cancelled out. So if you compare, you will be getting x is equals to 64. So you will be getting x is equals to 64 hours. It means that the base period will be same. But the discharge has changed. So that is why both A and B were not the answers. Although we did not calculate it, just by the linear response assumption, we calculated the peak discharge at 20 meter cube per second. But still, in options, base period was also mentioned. So just to make you understand that why these options were discarded, because the option should be now x is equals to 64 hours. If there would have been, you can say, E option also, this base period will same. The base period will be same, then both option D and option E were correct. Okay? But here only 4 options were there, so option D is the correct answer. Clear? So I hope that you have understood how to solve these types of numericals. So in unit hydrograph, the assumptions are very important. So assumptions type questions are coming directly from the assumptions. It can be a time invariance, it can be a linear response, right? So these types of questions are generally coming in examination, but most of the time either a triangular graph is given or either a trapezoidal graph is given. Even if you in the gate examination, even if you forget the concept, then what is the concept? Just compare the units, you will get the answer. Simple. Just compare the units, right? Want to calculate the area, divide volume with the effective rainfall depth, you will get the area. You want to calculate the volume, just calculate the area, it will give you volume. So that is how questions are solved based on the unit hydrograph. They're very simple, right? Now let's move forward and let's understand the concept of method of superposition. So already I have told you in the previous video also, previous lecture also, what is method of superposition. For example, we have a unit hydrograph of 4-hour duration, and after let us say 4 hours or 5 hours another unit hydrograph is there. So when both of them are combined, now what is the resultant hydrograph, right? So that comes in the method of superposition. So now let's understand the next topic, method of superposition. Thank you.